In our last video, we talked about some of the most basic concepts in graph theory. We talked about edges and vertices, we talked a little bit about loops, a special kind of edge, we talked about equivalent graphs, and so now that we kind of have an idea of what a graph is, it's probably a good idea to figure out what a graph is good for. There's a reason we have graphs. They make it easy to model relationships between things. And so we're going to look at a few different situations in which a graph can kind of simplify relationships that exist, either in a picture or in real life. Real life relationships can be modeled with graphs too. So let's start with my expertly drawn picture of a park. We'll call this King's Park. I don't know why we're calling it King's Park. Let's call it King's Park. And in King's Park, we've got a river and some islands and some shores and some bridges in between those islands. And so I've got a landmass up here, landmass down here, a couple of islands in the river, and I'm kind of wondering if there's an easier way for me to represent the information that's happening here. Maybe I want an idea of different ways to get from one landmass to another. So I could call, let's hope this shows up, let's call this, let me pick a big bright thing, let's call this landmass here at the north A. We'll call this little island here B, we'll call this island over here C, and we'll call this guy over here D. I could make a graph to represent ways to get from landmass to landmass. So I could have A, B, C, and D, and I'll go ahead and label those. So I had A, B, C, and D. And every time there's a bridge in between two of those landmasses, I can draw an edge on the graph. So I have two bridges between A and island B. I've got one bridge between A and C. I've got one bridge between B and C. And I've got two bridges between B and D. And so, and I have a bridge between D and C. Don't want to forget about that. So here I've got a graph that represents, this graph here, the vertices represent the different land masses, and the edges represent the bridges between the land masses. So I can see here that if I wanted to go from A to C, I could either cross right over, or maybe I want to take a trip over to the island, so I can take one of the bridges to the island and then go to C. Maybe I want to go to all of the land masses, so I start at A, go to B, go to C, end up at D, take another walk back, head back, and get back to A. So what this graph does is just allows us a simpler way to look at all of the information that we need from this particular picture over here. So that's one way that we can use a graph. Another way that we can use a graph, again, expert drawing of some of the fine states of the United States of America, maybe I want a graph that will show me whether or not two states border each other, whether or not they share a border. So I can actually do that. So we've got Montana and Idaho and Wyoming and Utah and Colorado. So I'm going to go ahead and model that over here. I got Montana, Idaho, Wyoming, Utah, and Colorado. And we'll call this M, call this I, call this W, call this C, call this U. So I've got a set of vertices now that match up with these states. And so now I'm going to look whether or not the two states share a border. And if they do share a border, I'm going to draw an edge. And so Montana and Idaho, they share a border, so I'm going to draw an edge. Montana and Wyoming, they share a border, I'm going to draw an edge there. Montana doesn't border any of the other states, so I don't need to draw another edge for Montana. I'm going to look at Idaho. Idaho borders Montana, we've already got that. It borders Wyoming, so I need to draw that edge. Idaho and Wyoming. Idaho also borders Utah, so I need an edge for I to U. So move on to Wyoming. Wyoming, we've already got Montana and Idaho. But Wyoming also borders Utah, so we'll draw an edge here and Wyoming borders Colorado, so I can draw an edge between Wyoming and Colorado. And last but not least, it looks like Colorado and Utah, I need that edge also. So now I've got a way of seeing which states share borders. I can look at this graph and I can see from this graph that Montana and Colorado don't share a border, that I would have to go through either Wyoming to get to Colorado, or I'd have to go through Idaho and Utah to get to Colorado, or Idaho and Wyoming to get to Colorado, but I can see which states share borders using this picture. It's a much simpler picture to look at than the picture of the actual states. Okay, another thing that we can do with graphs, oops, let me make sure I have this, just the picture that I need here. I've got a floor plan here of a floor of a house, and I want to draw a graph that models the way that these rooms are connected to each other, and also how the rooms are connected to the outside. So I have room A, B, C, and D. And we're going to call the outside E. And outside of the house can actually be a vertex. So let's make vertices for all of these things. I've got E, I've got A, I've got B, I've got C, and I've got D. And so I'll label these E, A, B, put the B out here, C, and D. And now I can go through and put in edges everywhere these rooms are connected to each other. So I have an edge between A and B. I can draw that. I have an edge between A and C. I can draw that. I have an edge between B and D. I'll draw that. I also have an edge between B and the outside. So I'm going to go ahead and draw that edge as well. I'll move on to room C. C is already connected to A. It's also connected to D, so I'll make sure I draw that edge. Now I can move on to room D. I've got a connection between D and B already. I have a connection between D and C already. I actually have two connections between D and the outside. I've got two doors that lead to the outside. So I can actually draw those like this. So those are actually two separate edges to represent the two separate ways to get from D to the outside. And then this graph actually models exactly what the relationships between those rooms are. That shows me that I can get from A to B, and I can get from A to C, but I have no way to get from A to D. Those two rooms are not connected in the house, so I have to go through another room to get to D. It shows that I have one way to get outside from B, that one edge, and it also shows that I have two ways to get outside from E, those two edges coming up from D to E. So that's another way that we can use graph theory to kind of simplify a picture or look at specific information that we want in a picture. Another way that's probably not covered in your book, but an interesting way that graph theory is used in everyday life is in my beautiful drawing of Facebook. Facebook, any type of social networking that you do uses graph theory. So let's say that you are a vertex. All right, so here's you. I'm going to call that you. And you've got a bunch of vertices around you, and those are your friends. These are people that you're friends with. So Facebook looks at your friends as vertices that are connected to you in a graph. So let's say you've got some person out here, and all of your friends, maybe not all of your friends, but a bunch of your friends know that person. But you don't have a connection to that person yet, so you're not connected to this person here. But three of your friends are. Facebook is going to assume that maybe you might know this person. If three of your close friends know somebody, there's a chance you might know them. So they're going to suggest, hey, maybe you want to check out and see whether or not you want to add this person as a friend on Facebook. And so your friend suggestions on Facebook don't come from just random places, although sometimes it seems that way. Your friend suggestions on Facebook come from graph theory. Graphs looking at which of the vertices that you're connected to are connected to other vertices. And so Facebook is social networking, and so much of the internet actually uses graph theory to figure out relationships between people or websites or pretty much any type of relationship that you can capture on the internet can be captured in graph theory. So that's going to do it for Graph Theory Basics 2. I'm going to do another video that will cover some more important terminology. We'll talk about circuits and paths and adjacent vertices. We'll talk about the degree of vertices, just all of the remaining terminology that you need to get through basic graph theory.